Okay, we're going to get started. Welcome to your Metro-style app, audio and video. We're going to talk about some of the basics today. We're going to set some context for some of the other sessions that you're going to see later about audio and video. But first, my name is Gabe Frost, and I'm a lead program manager in the Windows Multimedia Platform team, where we provide all of the operating system affordances that make it really easy for you to write applications, Metro-style applications, as well as traditional desktop applications that work great with media. These are things like codecs for audio and video, the underlying engines to support things like transcoding, to support playback, to support streaming, capturing from cameras and microphones on the system, etc. So we work really hard to make sure that all of those intricate details about how the platform does its job, how it does hardware acceleration, and how it just makes everything work easy. We make sure that all of those complexities are abstracted away from you so you can get right to business and focus on the details of your application instead of all of those complexities. I should have the clicker in my hand. So I thought a great way to sort of kick this off, to give you a sense of what we're talking about here, is to show some tailored applications for music and video that allow you to play back what you would expect to play back on any system. Trying to get a switcher. There it is. That was worthy of applause, that the switcher worked. You guys are going to have to bear with me today. So we're going to start out by talking about a simple tailored music application. So this application, when I say tailored, what I mean is that it does one thing really well. It doesn't try to do a whole bunch of different things. In this context, this music application gives you a view of the media that's on your system. And so that's really interesting in the context of web technologies. These applications that I'm going to show you today, all of them are written 100% in HTML, styled with CSS, and JavaScript. And so what's neat about this, and one of the key distinctions that we'd like you to walk away with today, is that you have complete access to what's on the system. In this case, these are all of the media files that are on the system. Now, those of you who've worked with the audio tag in the past in a browser are limited to some very specific formats. Another distinction that we'd like you to walk away with is that anything Windows can play, traditionally, things that you've seen in Windows Media Player and other applications where you're using those platform affordances, those codecs that exist in the system, your Metro-style applications can use as well in the video tag, as well as if you're using the media element if you're a C# or a C++ developer. So in this case here, I'm going to go ahead and just show you some of the basics here. So here we have I have my audio muted here. Don't worry about it. You'll see the method to my madness later. But you can play back audio. Actually, let's just go ahead and unmute for now, so you can hear it. Okay. So we're playing back music. We get access to rich metadata in these files that are on the local file system in my local music library. I can see the album art. I can see the name. There's all sorts of details, right, that you would expect to traditionally be able to access inside of your application. Right? I can look at different views of my music, right? So here we have a different way to look at the collection. I can look at it in the context of albums. I can look at it in the context of genres. etc. And so you're able to deliver very rich views using very simple APIs to access the local file system specific to media properties. I can do things like create playlists. So I can select multiple items and see some of the tools that are available to me inside of the app bar, this thing that you heard a little bit about yesterday, things where applications can put some of your controls. So here, I can add these things to the queue. So I have a queue of these items playing. I can clear my queue. I can save the queue. So I can do simple things with playlists. These are all things that you would expect to be able to do inside of a music application. It's tailored for experiencing music and not for doing all kinds of library management and things like that. Now, the same is true in a simple view of a video application. Again, I'd expect to be able to just see the videos that are in my library. I should be able to play those things back. These are all sorts of different files, whether it's a Windows Media Video file or an MPEG-4 file. All of these different formats that you've come to expect Windows to play will work inside of your Metro style applications independent of the language you use. This is especially important for those of you who are coding to the video tag and you've been limited to certain formats in various browsers. So the power of the platform is expressed by using these APIs. So let's go ahead and take a look at one here. So we have full, rich HD playback, full screen. It's very simple. I can scrub around. So this is all stuff that we just sort of expect to see inside of an application, but it is an illustration of some of those key meta points, which we'll continue to talk about as we go forward here. So I'm going to switch back. Okay, so it's easy to build media applications without having to worry about the complexity. So you can focus on delivering great tailored audio and video experiences inside of your application. We're going to walk through some of the details there. So I'm going to talk a little bit more about that as I go. I'm going to give you an overview really quickly of the media platform and what that means. Again, me and my team, we focus on those affordances to make it really easy for you. So we want to give you some context about what that looks like, how those pieces come together. Plus, it's an opportunity for us to show you one more box diagram. We like those things here. We're going to talk a little bit about HTML5 media elements, but I'm going to pause and we're going to discuss media elements in general for those of you who are C++ or C# developers who are used to perhaps maybe writing some Silverlight applications. We're going to talk about the programming model that we offer for Metro-style applications that's distinct and beyond the browser, things that you can do and expect to do inside of your Metro-style application that you perhaps wouldn't be able to do inside of a browser environment. And we're going to talk a little bit about formats, what that means to you. We're going to give you some very directed guidance and some rationale for why we've made some of the decisions that we have. Now, one of the things that I'm going to set myself up here for a demo I'm going to show you. But one of the key points that we want to make is a lot of people get confused about media. Well, first off, we oftentimes think that it's difficult because working with audio and video traditionally has been a little complex. But we also think about media in a light where perhaps it's not interesting to you because you're not building a media playback application. So I'd like to challenge you to think about media in a different light, to think about media in a way that makes your applications more rich and engaging, but isn't necessarily the focal point. It's one of those rich elements that you can add. And so I thought a great way to illustrate that is with the weather application. This app is beautiful. It uses a full screen video wallpaper, indexed lower than the other content. It's non-obtrusive. It's contextually aware. If I change between different cities, I can see what's going on in those different cities at a glance very quickly. It brings me into the application. Other ways that you can think about this, as a team, we started brainstorming this a lot. What are ways that you could think about media if you're not building applications to just play back media. And some of the things that we came up with, and we have some demo applications that we play with, are, when you think about maybe a reader application, you have a magazine or something, and you're an author and you're quoting someone who said something in an article. You can link directly to a video of a person actually saying the thing that you're quoting. Instead of just allowing people to comment, you can use the microphone and the camera to do rich video comments. You can think about audio and full video bookmarks if you want to make notes for yourself in the margin of those. So there's all sorts of ways for you to sort of open your mind to why media makes your application more engaging for users, more than just playing back media. So we challenge you to really think about that now that we've made it really easy for you to implement these features without having to deal with the complexities underneath. So there's 4 things. I mentioned some distinctions that we're going to go through today. And these are the things that I want you to think about as we talk and we go through some code samples. Right? 1, you don't have to be an expert about devices or the underlying hardware in order to use these media APIs. So you can take full advantage of hardware. I have some TVs and some receivers up here. Cameras, microphones. You don't need to know anything about those. You don't need to know anything about protocols for how to stream things on the network. We handle these using very simple contracts, right, that open up this sort of web of applications and devices for you to use. We thought that that was a really key thing, right? You saw that in the keynote in the context of photos and whatnot, and we're saying a very similar thing when we talk about that for devices. It's really easy to build Taylor applications that take on the look and feel of Windows. So there's a cohesiveness to your application. Jensen talked yesterday about building beautiful applications that flow well with the Metro style. They look great. So we have default controls in UI that you can use in order to take on that look and feel. Now, you don't have to. You can customize and you can style anything here, which we'll talk about in some subsequent sessions. But we've made it very, very easy for you to just do the absolute minimum, the smallest number of lines of code, and have it take on that look and feel of Windows. It's easy to use any media. Right? What I mean by that is the media, whether it's an audio, video, it can be on a web server that you're referencing using an URL. This is something that I think we're all accustomed to when we set the audio or video tag source. But you can also use media that's in your local library. You can use media that is on a home group connected PC in your home network. You can use it on these standards-based network-attached storage devices that are plugged into your network. We've abstracted the details away such that you can choose and use this media, create these rich experiences no matter where that media is. And it works the same, independent of where that media is. So I'll show some examples of how we do that. And last, the platform, the power of Windows, is completely extensible. And we're going to talk a little bit about that. But demanding scenarios like stereoscopic 3D, content protection, things that you previously haven't been able to do in browser-based implementations of HTML5, things that you're accustomed to doing if you're programming to the media element and Silverlight, for example. These are things that we've pushed down into the platform and made them very, very simple to use in a consistent way across all languages. Okay? And we'll go into some more detail there. So when I talk about the media platform, what does that mean? Again, we get to show you rectangles. We like that. Your Metro-style application, right? I'm making a point here not to distinguish how you've written this application, because really, truly, you may use your language of choice. Some things that we're all accustomed to is playback or capture, right? How many people in the room are like C#, C++ folks? All right. How many are web guys? Okay, I'll raise both my hands because I try. I'm terrible at both, but I try. In the context of C++, C#, Silverlight, that media element that you've become accustomed to using is a very natural experience when you're writing Metro-style applications and you want to do playback. If you're used to using audio and video from HTML5, it's equally natural, right? So from a playback perspective, the way that you do playback, it's the same. But then there's also these additional pieces of functionality that we add under the Windows runtime. And we do this by exposing them in a very nice, easy-to-understand namespace called windows.media. And we'll talk about that in a little bit going forward. But basically, they break down into capture, transcode, and streaming. And the media foundation in Windows is the underlying gobbledygook that you don't have to worry about when writing Metro-style applications. But if you really like to mess around in underlying gobbledygook, you may do that too, using Win32 APIs. This is all available to folks. And what that essentially is, what I'm showing here, is this media foundation are how all of the codecs, the encoders, the decoders, the built-in effects, the ability to do streaming, all these things are in this media foundation, and they're extensible. You may add your own formats. You may add your own codecs. You may add your own effects. And we have a session where we talk about that. In order to do that, you're going to write some C++ for the effects, but you can use those things very easily inside of your managed language, if you like. Now, what I didn't draw underneath Media Foundation here is the underlying metal, right? When we get down to it, under there is DirectX for video. We're all in, as you heard Alesh say, on DirectX 11. So every one of the video decoders, all of the video components in our system are hardware accelerated. Those are for things like color conversion. Anytime we mess with the pixels in a video, that's all hardware accelerated. And we're making a promise that the video decoders in the system are hardware accelerated using any DirectX 11 capable GPU. So as developers, you don't have to worry about that. You can expect that whether or not your application is running on an Intel processor or if it's running on an ARM chip, that we've made sure that there's consistency in the platform that enables your apps to be hardware accelerated. And this is true for audio as well, for audio offload. So all of these details are handled in the platform. You don't have to worry about them. We've made it very easy. So media elements. I say HTML5 media elements, and most of what we're going to talk about going forward is HTML5. I'm going to use a lot of JavaScript examples. I put some C# ones in there so that you guys don't throw tomatoes at me. But the key things to take away here, all of these things that I mention going forward applies as well if you're programming to the media element in C# VB or C++. And I'll make note of that as we go. So as a quick primer on HTML5 audio and video, this is the implementation of the W3C spec. So this is a standards-based thing. You took it for a dry run in Internet Explorer 9. Amazing work. But it was in the browser. So what we did, actually, we were the team that worked very closely with the IE team to actually implement that audio and video tag in Internet Explorer 9. But what we did going forward is we took all of that work and we put it down in the platform. So think about Internet Explorer as another Metro-style application, just like yours. They're using the same platform, right? So anything that happens in the browsers, hitting the same code paths as Metro-style applications. So you can create these rich experiences. I showed you an example of one earlier using the video and the music application. Right? So you can create these rich experiences that are styled. You have access to the DOM elements. It's natural to program these things. So keep doing what you're doing, and you can create these very, very rich experiences. However, you also have access to some of the things using the Windows runtime that you previously haven't had access to, like access to local files, the metadata in those files, etc. right? Fully hardware accelerated. So methods and attributes, all the things that you would expect to see on an audio and video tag, you have. Right? Here's another example of some of the events that you would see fired on the video tag. So let's go ahead and deconstruct some of the things that we saw in those audio and video demonstrations that I did earlier. Right? This is sort of basic. We have a couple tags here. I'm showing off a couple of attributes. This is just some static HTML where I can set the source to something. Some key things to notice here. First, you see all kinds of different audio and video formats there. So that's new. Anything Windows can play, you can play inside of your video tag or your audio tag. I showed how to queue up some media items inside of that application, right? So if you're a JavaScript developer, you can listen, for example, here I'm showing a very, very simple, a dulled down approach to how you can create a queue of media items. So I have an audio tag that I have track 1 playing on. This track happens to be MP3, and it automatically starts playing. But I want to know when that track ends so that I can add the next song that's in the queue. So using the straightforward standards event-based model for JavaScript, I listen for when that track ends, and I set the source to my new track. Because I'm auto-playing, that track automatically starts. This new track is a AAC file. We access local files here. We saw some demonstrations of using the picker. Alesh was coding that up on the fly here. So there's different ways that you can do that. You can invoke a picker and get a very tailored experience, a very mosh experience. Sorry, I'm using an internal word there, a very Metro-style experience. Right? So here what we're doing is we're invoking a file picker in order for the user to go pick a file. And we're using this pattern, this then pattern, because all these APIs are asynchronous, right? You could code this up. For those of you who are used to, coding in JavaScript, you can, do all of your event listeners and you can code it up all that way, but it gets to be sort of hard to keep track of, which functions are handling what. And so we create this pattern that makes it sort of straightforward for you to tier all these different asynchronous functions here. So we pick a file. When we get that file, we convert it into a URL so that we can set it to the source of the video tag in this context. So it makes it very, very simple to allow the user to browse the file system, choose a video, and have it play back inside of the video tag. Another way that you can do that is you can programmatically go straight to the files. You can build your own view of what's happening in the files if you don't want to use that built-in picker and allow the user to choose. Here, we're showing how to get access to a MP3 track inside of the music library using a very straightforward API. When I have this file, I'm then able to actually look at the music properties of this file. The same is true for videos or photos. So I can look at each of, album, artist, title. These are things that you saw in that application. You can pull out the rich metadata. You can pull out the thumbnail for that file in order to display some album art or a frame inside of that video to show to users as the poster inside of a video element, for example. So this is very, very simple. This is very straightforward to do these things, right? So those are 3 very basic things for how you can access to. I actually want to very quickly mention, as I say in my comment here, here's an example of using the windows.storage namespace to access files that are local, right? You can also, as a known folder, you can see those network-attached storage devices that are on the network. You can see the shared PCs. So we've made it very easy. We've abstracted away the details of how connectivity happens for devices and for other PCs, and made it very easy for you to allow users of your application to get access to this media. So that's a meta point worth mentioning, something that Windows, sort of the power of that platform, brings out. Now, let's talk a little bit about things that you can do outside of what you've been accustomed to doing in the browser, or something that maybe you've been accustomed to doing in your Silverlight applications that we've brought into the platform, and we're exposing via this very simple namespace. So first, stereoscopic 3D. You can play 3D video inside of a video tag for hardware that supports it. You don't have to worry about the details. There's some very simple APIs that you can check to see whether or not the machine is capable of it. In the follow-up session, part 2, we're going to go into a little bit more detail there. Effects and extensibility. I mentioned that if there's a format that you care about that Windows doesn't support, you can add that for your application. If there are wacky effects or things that you want to do, a very simple one is, maybe you want to make the video grayscale, or maybe you want to, draw a hat or a smiley face on, people doing some crazy face detection or something like that, right? The full power, each individual frame of audio or video is available to you in this extension model. And you can use that inside of your Metro-style applications. You can package that up and include it in your application and differentiate in those ways. Output selection on the audio and the video tag. So you can, for example, send audio to a Bluetooth headset or to some Bluetooth speakers or to some headphones somewhere. So you have the full ability to enumerate these devices, these audio devices. You can also enumerate the different inputs. And so you have control over the experience, which becomes interesting, for example, in communications applications, which we'll also have a dedicated session to. Background audio is something we should just expect to work in this Metro experience where you're effortlessly switching between applications. I don't want the audio to stop when I start web browsing, right? So we've done some things to enrich the audio and the video tag so that you can specify, for example, a type of application. If you're a game or if you're a navigation application, these are the types of things that we're thinking about to make sure experiences that we have on our phones already, we would expect to also work in this environment as well. So we've thought a lot about that. Content protection, such as Play Ready. No more separate downloads. It all just works. Using that extensibility model that I mentioned before. If you really like to get down in the nuts and bolts and you have your own form of content protection system, you may plug that in and use that in your application. And that'll work seamlessly inside of the audio and the video tag, right? This is important for that high-value content streaming from marketplaces, for example. Low latency is very, very important for these communication-style applications. It's very important that we allow developers, to tell the system that this is a communications application and you should optimize for latency, right? We provide some different views for the video tag so that you can say, I want mirroring mode so that it actually looks right when you're looking at yourself in the camera doing these communications style applications, or you want to zoom in to get rid of the black lines on the video. So we've thought a lot about these things, and we allow you to decorate the audio and the video tag with these new capabilities in order to create very, very rich applications. So let's talk a little bit about the programming model. How many have been to a professional developers conference before? I imagine most of you, right? So we used to describe you with these personas, and we talked about them oftentimes. There was Mort, there was Einstein, there was Ichiro. But there was never that guy who wanted to do the least amount of work and get rich, right? Like, that persona didn't exist, and that was something I always kind of hoped for, right? People who have these great ideas and you want to execute on those things very, very quickly. Well, Mort and Ichiro and Einstein were the ones who created big specs and, you really thought through, and it was an application that did everything under the sun, right? So we wanted to make this really, really simple for that persona of the person who wants to execute on your idea really quickly, get it on the store, and make a lot of money, right? So we've organized all of these capabilities that I talked about into a very simple namespace, which you can find under windows.media, right? And so what you see here are some of the basics. You've seen a lot of demos here. Capturing from the microphone and from the built-in camera, whether there's multiple cameras or not, you have full access to all that. Input and output audio devices, if you want to work with playlists, if you want to stream to devices in your home, like these here. Hint, hint, we're going to show something there later. Content protection, if you want to do transcoding between if you want to change a file, for example, from, say, a Windows Media Video file to an MP4 file, or if you want to change the bit rate, you want to just make it work on your small device by getting it there. We make that really easy for you to do. And video effects, right? So let's take a look at, these are some of the things, before I move on here, these are some of the things that go beyond that basics, right? There's playback. We all know how to do playback. We've all been doing it for a long time. I'm projecting that you've all written media applications here. But, you know, it's fairly familiar. The stuff's been out there. Those of you who've played around with audio and video tags or the media element in C# or C++ or VB. It's these additional things that we're lighting up in the platform. These are those WinRT APIs that are exposed where, you know, we make it very, very straightforward and simple. So let's take a look at Play 2. So many connectors. This one. Okay. So I know that I don't like, if I'm sitting on my couch with my brand new developer preview hardware, and I want to listen to the music, I don't want to listen to it on my tablet. I want to listen to it in my living room. I want to make that work great. So let's take a look at that. So here I'm just in my music application, and I like this band. I might pick a different song that's maybe a little more energetic. Let's find one. Drowning. I don't like the name of that one. Bear with me. I should just use the search contract and go straight to it. Okay, let's listen to this one. So here's my song. Again, I'm muted. Can't really hear all this stuff. But I don't want to listen to it here. I want to listen to it on my device. This is an application that implements a Play 2 contract. You heard about contracts before for things like share and search. Well, we have contracts for devices as well, and Play 2 is one of those. This application implements that contract, so I can say that I want to stream my music to my bedroom speakers. So we have the audio coming out of this receiver into the room so you can hear it. Okay, so that was really easy. You can probably see it playing in the front of here. I have full control of this. I can pause it right from my control. I've turned my control in my application into a remote control over the network. So let's play that again. I can seek around just as I expect to be able to seek around. Right? So that's great. You know, I don't want to stay inside that application. I want to listen to my music. I want to maybe take a look at some video. I like to surf. I have this surfing video. But, you know, I also want to watch this thing up on my big TV. And I should be able to do both these things at the same time. They're different devices. For those of you who can't see the TV, let's steal the video feed and send it up there. So you're seeing me from one application play music into my living room, and from another application stream to a TV. Again, I have all the controls to be able to work with these things. Another thing that you'll see is in the video application. Let's stop that music. It's a little inside, you know, of these applications. I should be able to very seamlessly send to devices, and we've made that very, very simple. We've hid all the complexities. It's 5 lines of code or less to implement that contract so that any of the media elements that you're programming to will just work with these devices. We're not taking questions in the middle, but... So let's take a look at what happened there, what was going on. I'll get to your question. Right? Actually, a few points. So I showed the music and video application here. You saw an experience of the photo application during the keynote, right? This is something that also works. It works brilliantly with photos as well as music and video. And it also works with Internet Explorer. It's another Metro-style application that's implemented this Play 2 contract. So every HTML5 website today works with Play 2. Every one. Right from within the browser. We had some internet connectivity problems, but we're going to show that in a session specifically for Play 2 later. But any web page that you connect to, whether it's audio or whether it's video or it's an experience with photos, just works. And you can stream that directly to the Play 2 receiver devices, and it all works the way you would expect. You still have the same control over what's happening. You can use the remote control of the device, and you can use that too in order to control it. And it automatically, as you would expect, updates the transport controls in the application. But we've hid all of those complexities from you. You don't have to worry about the details of what's happening there on the network or what's happening to the control. So let's deconstruct what we saw there. I mentioned that there's this Play 2 contract. So first, we call that a Play 2 manager. And your app can have different views. It can be drawing all over the place. And so you want to new up a Play 2 manager for the current view of your application. And this is the contract that you're interacting with. Right? Step 2 is you want to know when the user, when they swipe over the charms, the bar with the charms in it, you want to know when they hit the device button. Right? So when they hit the device button, it's important to know whether the application at this time has implemented the contract, actually supports streaming the media inside of that application to it. So there's an event that you listen to, just like in the audio tag I showed you before, you listen to that ended event before you assign the new here. Here we have an event called a source requested. The Play 2 manager wants to know what is the source of the media that you want to stream. Right? So you, at this point, set the source of the specific media item that you care about, which is an important point because let's say, for example, this device, this Onkyo receiver, it doesn't support video, it only supports audio. I wouldn't want a user of my application to send a video to a device that it can't play on and then have them call you and tell you that the device isn't working well with your application. So we use the source of, we actually use the media content that's sent to it to filter the devices that are in that list to make sure that whatever the media content it is going to play. And so when you set the source, at this point, Windows handles everything. It streams the media. As soon as you set the source, we draw the devices in there. The user chooses the device. You don't have to know anything about the devices. As soon as they choose the device, the media streams to the device. Whenever they hit play and pause and all those things in your application, all of that is handled for you. You don't have to worry about that. The great thing is, if you really want to do some special things, there's APIs to do that. But you don't have to. It's very, very simple. Now, for you C# developers, this is what it looks like in C#. I'm going to do a little back and forth. It looks identical. The APIs in WinRT are projected in a natural way. You can program to them in the same natural way you would expect to in your language. Okay? Capture. You saw this a lot. Let's go ahead and take a look at what the capture experience looks like. Let's change my user tile real quick. Say I want to take a look at the webcam. Here I'm doing something very, very simple. I'm just invoking a camera capture dialog. From within this experience, I can say whether I want to do video, whether I want to do audio. I can change some settings. For example, if I want to turn on video stabilization, so that all my bouncing around, this is especially important with these handheld devices if you're capturing video. We smooth out that video so that it just works. All these things you can do very, very simply. Go back to the PowerPoint. So let's take a look at that. First, you have to declare, this is the XML file you saw, usually you do that in a pretty Visual Studio, where you check a box and say, I want access to the microphone and I want access to the camera. This is what the XML looks like if you were to open that file. So you need to declare access to this. Otherwise, when you call this API, windows.media.camera.camera capture UI, if you call that, you'll get back an access violation because you don't have access to that. The first time that you use it, you see the dialog, you user, do you want to allow this application to access that? So this is a brokered access to the device because there's privacy concerns associated with it. Right? So this is very, very simple. Here I have an image tag. I don't have the source set on the image tag. I just want to take a photo, and I want to assign that photo to the image tag. So I invoke the camera capture UI, and I set the mode. There's 3 modes. There's I want to take a photo, there's I want to take a video, or I want to allow photo or video inside of the application. So you set that in the camera capture UI.mode there. And once you have that captured item, I'm taking that capture item, and I'm converting it into a URL using create object. I'm pointing down here like you can see it. Up there, create object URL, right? And I'm actually setting that as a source. So it's very straightforward, very, very simple. You'll have all these slides, so you can take a look at it too. So we talked about Play 2. We talked about camera capture. Let's talk a little bit about transcoding. So we've made it very simple for you to create experiences that allow users to convert their media files. And we've all, those of us who want to have our media play anywhere. If I have a device and I have a media file and I want it to play on the device, I need to convert it to something that actually works on that device. Now, fortunately, we've made that very, very easy in the overall end-to-end experience in the UI. But if you want to build that experience inside of your application, here's an example of how we do it. Right, so we have this app we call Simple Encode. It's very, very simple. Right? So let's just say that I want to take, my birthday video. Okay. This is where I hide what I'm doing. Oh, I'm not doing a good job hiding it. I don't know what's going on with that, but let's start it over. Like I said, you need to bear with me today. Okay. So here we have our video. I just opened it up. This application is very simple. I mentioned before, I showed a little code snippet of how you can programmatically access what's in the media libraries, and you can build your own view. This is an example of that. Rather than using the file picker to go pick it, I just built a little view of the video files that are in my video library. And I selected the little birthday party here because I want to edit it. And let's say that I have a device that does, this is a HD video, and I just want it to be converted into something that fits on a very small screen. So I just select one of the default profiles that we provide for you. We provide a rich set of defaults that work across a very broad array of devices. And let's just call this thing tiny. So all I'm doing here is I'm converting. You notice it happens very, very quickly. We're taking advantage of the GPU in the system in order to do this transcode operation. We took something that was HD and we squashed it down into something that'll fit on a phone. Let's go ahead and take a look at that. We'll open up the video application real quick. Look for tiny. There it is. And let's play that. So this is a tiny version of that same HD video, transcoded down to something really small in, what was that, like maybe 3 seconds or so, right? But what if I also want to do something very simple, like I just care about a very specific part of that video. I want to do a very, very simple edit. We can do that too. So let's go ahead and open the same same birthday video, but I just want to trim it. Let's say I want, let's find where it is. If I can grab this, it's a lot easier with a touch. There we go. I just want this little section of the video. And, I want to keep the resolution. I just want it small. I know this is a 720p video that's MP4. So again, right? You'll see this happen really quickly. What we're doing here is we're smart about the process, and we know that the user's not asking, the caller of this API is not asking us to convert anything about the video. They just want a very small part of it. So we actually just re-multiplex that, and you don't actually get any degradation in the quality. Now this is also important too. We have all these different file formats and codecs and whatnot, and sometimes what you really just want is something in a different file format, but you want the codec, the actual compression scheme on the video file to be the same, or maybe the audio file to be the same. So we're smart about that when you call these APIs, and we just do a remultiplex of the file format, and we don't actually touch the audio and video. So we've done a lot of work to make sure that we optimize for quality. We're not having to do any lossy operations if we don't have to. And we've made sure that we've optimized for the underlying hardware so that it happens as efficiently as possible across a range of form factors. Okay, so let's go ahead and take a look at that just real quick. I have my trimmed, my very tiny little portion of that video that I created there. You'll see there's no quality degradation whatsoever. So let's take a look at how we did that. So the first thing that we need to do, what you're seeing here is we're creating a transcoder object, a media transcoder, and we're selecting a profile that we want to use. Now I mentioned before you can select from some predefined profiles that are optimized for various devices that are popular in the market today. Or you can get in there and twiddle the bits and say, I want exactly this bit rate, or I want exactly this resolution. So in this very simple case, we're just going to use a standard profile here. Right? We need to define what is the output. We need to create that output file. We need to define what the input file is. In this case, I'm actually going to convert a Windows Media Video file into an MPEG-4, specifically at VGA quality. Right? These are all asynchronous APIs, so again, you're seeing this asynchronous then pattern here. Right? And then I want to transcode the file. Once I know I have my transcoder, I have my input and my output file, simply calling transcode file async here with the input file, the output file, and the profile, and we're done. Right? In the second scenario that I showed, we don't need to create a profile because we're not changing the profile. We just simply want to trim. So in this case, we're defining what the start time and the stop time is, but otherwise you call the API exactly the same way. So you specify your input file and your output file. In this case, they're both MPEG-4. One of them is just smaller. I'm calling it vacation and edited vacation. And I'm calling the API with the input and the output. And it remuxes that file without touching the video quality at all. So let's talk about formats a little bit. This will be a coming-of-age tale. So historically, in Windows, there's been codec packs and all sorts of things that you can do, you can install in the system. And what we've found over time is that a badly written plugin that happens in the system impacts all your applications. We don't want a situation where a component in the system can impact the overall quality of your applications. So we've changed the model in this next version of Windows to sandbox each individual application. Right? So we have a set of system formats, system-wide, that are all hardware accelerated. They're very well tested. We do a lot of work on these things to make sure that they play back every range that you can think of. Right? And it's our recommendation to you to use MPEG-4. we're all in on H.264 and MPEG-4. We've worked heavily on this. We're putting a tremendous amount of effort into this. This is something that you saw, again, starting with Internet Explorer 9, with our support of HTML5, right? We've taken all that, we've put it down in the platform, and we've continued to work really hard. Memory savings, make sure that these things run really, really well, taking advantage of all the hardware, taking the least amount of memory footprint possible. So we recommend MP4 or ASF for Windows media files, but we prefer MPEG-4. For video, H.264 or VC1. Audio, there's 3. These are our preferred compressed, AAC, MP3, Windows Media Audio. We have broad hardware support across all the range of form factors and CPU architectures. And if you're building applications to use media, please heed our recommendations. If you use other formats, you could have impact on quality. You may not have hardware acceleration on those. And these are a promise that we're making and requirements that we have across all form factors, all of our partners that we work with who are building systems, to make sure that all of these are very well tested and are fully hardware accelerated. Now, in your application, I mentioned that you can package your own plugins. Right? So if there is a format that isn't in that list, and media is very nuanced, and there's all sorts of different versions, and we're not going to go into that level of depth here, in terms of like what are the bit rates and what are the different levels and whatnot. But from a system-wide perspective, when you're building applications, this is what we recommend. But there are formats that you may want to include. Maybe you're doing something with adaptive bitrate streaming, and you have a service on the other end, like a marketplace service, and you want to include this in your application. You may do so. You may have input-output processing plugins. We have a full extensible model for you to plug all of these things into the system. You're going to write some C++. We have a very simple WinRT API. Once you have this, you got a DLL that has this functionality in it. You can load that DLL inside of your application, and then it just works. So let's take something random and say XYZ format. You build support for parsing this format. You know how to extract out the elementary streams in this format and send them down to be decoded by the system. If you put this XYZ format or this plugin in your application, and then you see an XYZ format file, and you set that as the source of the video tag, it'll just play. Right, so it's very, very simple once you register this inside of your application. So we have system-wide support. If you want to extend, you may, but that extension will be limited to your specific application. What does that mean? If there's a plugin that everybody in the audience wants to use inside of your application, every one of you will include that plugin inside of your application when you package it up and submit it to the store. Okay? So we talked about some key things that distinguish your Metro-style applications on Windows from a media perspective, taking advantage of graphics, hardware, and devices without knowing anything about them. You don't have to worry about the details. It's easy to build experiences when you use default controls and UI. Takes on the look and feel of Windows. You don't have to do a whole lot of work. You may customize to your heart's content, but we've made it very, very simple for those of you who don't have a desire to do so, which I think traditionally is kind of a reversal of the model that we followed. It's simple to use media from anywhere, whether that media is on a web server, whether it's on your local file system, whether it's on a network-connected PC in your home. And we provide these demanding scenarios like stereoscopic 3D, DRM, streaming. All these functionalities come out of the platform through the set of WinRT APIs and Windows.media. I mentioned when I started that this session is an introduction. Think of it as a primer. We wanted to talk about some key concepts, like you may use your language of choice. If you're comfortable using a media element, you've done Silverlight coding before, this will be a very natural transition for you. It will be very straightforward. If you're used to using, I'm looking this way and this way. I saw some HTML developers over here. If you're used to using the audio and video tag, you're going to be right at home writing these applications. But there's a number of other sessions that we have following that go into the details of these things, right? And they're listed here. So we have part 2 in the same room, I believe. Daniel, nod. In the same room where we go into some more details, right? Like how does background audio work? How do you do that? How do you deal with stereoscopic 3D or these types of things, plugins? Foundations for creating communications applications. How to actually write these plugins and use them in your system, right? How, if you're interested in creating a device or you want to understand how Play 2 works with these devices and you want to see more Play 2 demos, right? We have another session on how to do Play 2. So anyway, we have a great deal of sessions here. We go through. We've created some papers that you can read if you want to go into some more detail on these things. And we're going to be very actively watching the forums. So if you have any questions at all, please post them on the forums as you're developing your applications. Now lastly, we're going to be, those of us in the room here in media, we're going to be heading over to the expo. And you can look for walls that look very much like this insane red color that's staring you in the face. Over in the expos, they say platform. We're going to be over there. We're happy to answer any questions that you have. We're so appreciative that you're here today, and thank you for your time.